moving to COVID. Okay. So, what is our understanding upon the coronaviruses? What happens is that the set of viruses which are RNA viruses and have a corona-like of structure, like the king's crown we have, right? So that crown kind of structure they have around their emblem. So they are called as coronaviruses. So they are generally RNA viruses and they mutate very easily and they infect a wide range of mammals as well as birds. But in case of humans, there are 3 to 4 types of coronaviruses which actually infect human as well. So one of them is the most common influenza virus that we have during the regular cold that we face in rainy season and in most of the other cold weather conditions. So that is one of the type of coronavirus as well. So the fear that we have against coronaviruses because of this COVID-19, we have to start living with it. And there has been speculations that this particular COVID-19 may also turn into a seasonal pandemic like COVID.
Dharala, madam is not audible, please. Madam is not audible. Could you please make sure that she is audible? The speaker is not so audible.
Yes,
It
Father.
won't. Hello.
Dr. Ira, excuse me, Dr.
Yeah.
Ira Bhatnagar, ma'am, could you please unmute yourself and increase your volume because Father says you're not audible.
I am on mute only. It is
Okay,
on mute.
could you please increase your volume, ma'am?
Just a minute. Is it okay now?
Yes, ma'am, better.
Is
Thank
it
you, ma'am.
okay?
Yes, ma'am.
Okay. So what happens is this virus has two of the structures. One is the spike proteins and then the nucleocapsid. You can see this zigzag kind of pink kind of structure, right? So this is the nucleocapsid of the virus. Both of these are very important for us because the nucleocapsid is generally used for as a marker in diagnostic assays, and the spike proteins generally are used for the vaccine development because they are the immunogenic part of the virus. So it consists of two regions: S1, which is responsible for the host cell receptor binding, and S2, which is responsible for the membrane fusion. Now, what happened suddenly one fine day morning in December, we all had been sitting watching television, we were busy doing our daily courses, we were chatting, busy over our phone calls, and suddenly this news surfaced up in our news channels that there is some cluster of pneumonia kind of cases in Wuhan, China, and slowly it picked up from there. So it was lately in the end of December that all these things started from China, and suddenly it spread globally. You won't believe this is the first case after SARS. Of course, SARS was also not that infectious, but post SARS, this is the first case in which the outbreak was actually considered as a pandemic within a month of its spread. You can see I have mentioned some dates here which are very important for you because I'm sure these are going to be asked in most of your entrance examinations as quiz questions. So MCQs. So better be ready with those dates. So it was on 30th January 20 that WHO actually announced it as a pandemic, and then on 11th of February 2020 it was named as COVID-19. Face of the disease. What happens is this disease actually spreads in stages. So the first stage is only when the people, transmit from the country of origin of the virus, like China, when they have migrated from there to India or different countries, because international travel is very common these days, and especially China, because most of the countries in India have, most of the countries in the world have Chinese companies with them. So people keep on going traveling here and there, and because of both the primary contacts and then the secondary contacts, slowly it goes to stage 2, which is the local transmission when you are getting in contact with the infected person. Then it goes to stage 3 when it becomes a community transfer, and from there, from the community transmission, it spreads very widely. Okay, and in the stage 4, it becomes like an epidemic where you can't see any endpoint of the spread. This is perhaps the case in America as of now. We have seen the bad situation in Italy a month back, and I think America is also on the same line now. If you see on the right hand side panel of the slide, you see I have shown you the global status, okay, global status of the pandemic. You can notice that on this light yellow shade, where only 1 to 100 number of cases are available, it is only in Australia, and now it shows in China and Australia. Just imagine the widespread spread of this particular virus. These dark colored dots are where the maximum destruction has happened, which is in most of the Americas, region of the America. Okay, even India is not very far off. We also have almost more than a lakh case now. Okay, so when I was telling you about the structure of the virus, I missed to mention that even a single point mutation in this particular virus can actually lead to the more infectious cases of this particular virus. Okay, so now that we know that we have some human strains of coronaviruses which actually can infect us, so how different are they? What is the difference between their genetic makeup, that one is more infectious, the other one is not that infectious? How can they infect humans other than mammals and reptiles? So if you can see here, being biotechnology students and faculty, you must have read about the genetic makeup of the viruses as well. So when we say we are also calling this COVID-19 as SARS-CoV-2, right? SARS-CoV-2. So why do we call it SARS-CoV-2? Because it is very similar to SARS virus. Okay, you see here I have deviated it on the left hand side of my slide panel. In the SARS-CoV virus, it uses ACE2 receptors, okay, angiotensin converting enzyme. ACE, the full form of ACE is angiotensin converting enzyme. So ACE receptor is widespread in our body. Okay, so SARS virus actually uses ACE2 receptor. COVID also uses ACE2 receptors. Same kind of receptor binding and inhibitors are available for both of these. Okay, but when we are using the SARS convalescent plasma for neutralizing this virus, we are not able to achieve complete results. Okay, this may be because it is not that particular virus, it may have some other mutations as well. So what happened is, when I say that it is very close relative, it is the first cousin, or you can maybe say it is a sibling of SARS virus, but it is smarter than the SARS virus. How? Why? Both the questions. What happens is, the SARS virus actually used to use the ACE receptors of the throat region. Okay, and that is how you get all the cough and agitations in the throat. But this virus is a little smarter. Now it uses the ACE receptors of the lower respiratory tract in your lungs, and thereby it suppresses all your lung tissues, so you are unable to breathe properly. And in the SARS virus, what happened is, because it is in the throat, you start getting cough immediately after the infection, within a day or two. But in case of SARS-CoV-2, you get the symptoms only after 10 days, because it is going to the lower respiratory tract, where it is causing all the damage. After the damage is done, it is showing you the symptoms. Okay, so it is much more dangerous. But as I told you, a single nucleotide mutation in the receptor binding protein of this particular virus can further increase its mortality. You need to be really careful about that, and you need to find a vaccine before it actually Okay, so how does this virus pass from each other, from one nucleus to another? This is a once upon a time story now. You have been reading about it in all the newspapers, and you've been hearing about it in all the news channels, but do we really give an ear to all these things? Okay, so that's why the things that we see more, we relate more. So that's why I'm showing you here on my slide that WHO has told that it can be a fomite infection as well. Fomite means from the surface infection. So it can come on the tissues when you are sneezing, and you can touch the same doorknob, and then there are digital devices which you are using, like my phone. Sometimes my phone is on my charging, and I call my son to pick it up and give it to me, so he also touches it. Sort of mismatch there. And then there are laptops, mouses. Right now I'm using my husband's wireless mouse, so it may also be one of the points of contact, right? So there are lift buttons that can also be infected because of this. So we have to be very careful about this. Very important aspect in this particular infection is the symptoms. What happens in this infected cycle? Why it is much more dangerous than antibiotics? So in the infected cycle, what happens is that the SARS virus actually, the COVID virus actually infects the ACE2 receptor, and it abuses this ACE2 receptor and goes the exchange of oxygen and CO2 does not happen in the lungs. And when this does not happen, the amount of CO2 increases in your the endothelial layers. So once it lines it there will be very less space left for the blood to flow, and thereby you will be having microvascular dysfunction. Also, it will be lining the endothelial cells as such, and it will be sequestering those endothelial cells. So you will be having macrovascular dysfunction as well. So vascularization will be affected. So the blood flow inside the body will not be proper. Your heart will have more of pressure to hold. So thereby you have a cardiac arrest. That is why it is very serious virus rather than the SARS virus.
Fine now? Is it okay? Okay. So, what are the alarms that we can?
Madam,
Hello?
madam, please use your earphones, madam, if you have, because you know there is a lot of gap when you speak. Could you please use earphones if you have? That would be.
Yeah, I just took them off because I thought that you are unable to hear because of
Now
this.
you are fine, madam.
But how will you differentiate whether it is a flu or a COVID virus? Okay, what happens is in flu there will be more of fever that can last for 2 to 4 days, and it is very common in coronavirus. In the case of somebody is asking me to remove my earphone, so I'll just try that for some few slides. I don't know why you people are unable to hear me. The voice is quite high with me. Hello. Okay. Okay. So I have presented it here on my slide. You can take a screenshot of this particular slide, and you can just read about it. That what is the difference between a common flu and a coronavirus flu. I'll leave it for you for 2 minutes so that you can just take a screenshot of it. Okay. There will be fatigue, weakness. More importantly, there have now been cases where coronavirus has actually started exploiting the stomach. Okay, so when it reaches the stomach, what happens is you get diarrhea kind of symptoms. Okay, so these diarrhea kind of symptoms, you can immediately you have to go and see the doctor if you have abdominal pain now with this COVID related problems. Okay, you need to go to the doctor if you are having fever together with the abdominal pain. Okay, just see the doctor then. Now, coming to the diagnosis of this particular virus, there are many ways in which you can diagnose this virus. Okay, not just this virus, most of the viruses for that matter. So the first thing is NAT, that is the nucleic acid amplification test. This NAT actually is the most commonly used test all over the world. Okay, so generally what happens is we detect a unique sequence of the virus RNA by nucleic acid test. Usually we employ a reverse transcription reaction to this, and then we synthesize cDNA, and then we do a RT-PCR, real-time RT-PCR, okay, for nucleic acid sequencing. But this is not a very foolproof method. Why? Because it has some discordant results, because there may be some possibility of contamination when you are handling it, and there may be some other issues when you are taking the sample from. Mostly problem happens because the sample collection site is different, transportation is involved, and then you open the samples vials here and then you do. So if there is lack of coordination between the cataloging, you may have discordant results. So all these things matter a lot when you are doing the viral diagnosis. Serological testings is second to NAT testing. Serological testing means blood-based testings. So in which what happens is it actually helps the NAT.
It is complementary to the NAT testing. When the ongoing outbreak is there, then only you can do this kind of testing. Okay, so it can even help you in assessing what can be the risk ratio for this particular disease to spread. But in serological testing, there is an issue of cross reactivity. For example, that one particular antibody, because we are not raising monoclonal antibody inside our body, we are actually raising common IgG, IgM antibodies, right? You must have read in the immunology chapters. So because it is a common IgG, IgM antibody, it can be having cross reactivity with other coronaviruses as well, because it's not very particular about this. Viral sequencing is another way of detecting the virus, but in this case, you need to have whole lot of virus for sequencing. Okay, we at CCMB, we are doing next-gen sequencing of the virus, but we need a whole lot of virus for this, I'm sure. Okay, and it is not very highly recommended method of doing it. And if you need a very high viral load in the clinical sample for this, viral culture, not recommended as a routine diagnostic assay. You must at some point of the time you must have gone for a urine culture in your lives. What happens is we do the urine culture for the pus cells as well as for the bacterial infections, right? So within 24 hours, you can culture the bacteria and you can tell that what kind of bacteria it is, whether bacteria is present or not, what kind of bacteria it is, and then what is the sensitivity and resistance of this bacteria against different antibiotics available in the market. But in case of virus, forget it. We are really having a very tough time in culturing viruses right now. Okay, especially the COVID-19, we don't know what cells it will grow and what will be the best media system for this virus to support its growth. All very difficult. So it is not very highly recommended. Okay, then there are, when we talk about the immunoassays, as I told you, there may be antibody-based tests and the body takes a lot of time to make up your antibodies. So in this case, if the virus infection has happened and after a gap of 1 week to 10 days only, you can get a testing done, because otherwise you may get false positives and false negative results, right? Because it can tell you whether it is positive or not. So this actually detects a specific IgA and IgG against the virus in the blood of infected patients. And we have fluorescent immunoassays, which are done generally in the sample collection centers to tell the IgG and IgM viral antigen load. Okay, on the right hand side of the panel, it is very important because we all know that testing is being done. But what kind of testing it is, we have to have a clarity about that, right? At least as science students. So what happens is the sample is collected and then it is centrifuged to separate the serum, and from the serum then it will be put in one of the machines for fluorescence testing, where already the antigen will be present for this particular virus, and then antigen antibody reaction will happen and a color reaction will show up. This color is actually detected as a positive signal in the machine. So this is how this test is done in most of the diagnostic laboratories. Now there is another test which can be done. This is an antigen test. Antigen tests actually are more sensitive ones, but I don't know whether I should call it as more sensitive ones, but at least it will be very helpful for us for early diagnosis, because the body takes its own time to develop antibodies, right? But the antigen will be present right when the virus has infected you. So if you have a little doubt, even if you are asymptomatic but you have a little doubt, the swab is taken from the nasal route or from the throat, and then this swab is used for RNA isolation, cDNA synthesis, reverse transcription, okay, to check for the presence of the viral antigen. There may also be lateral flow devices, if you can see on the right hand side of the panel, in which we can do antibody tests as well as antigen tests. You have antibodies immobilized on the test line, just like our regular pregnancy test kit. Okay, so the same kind of principle is applied here, and the antigen, the antibody present in the serum can be detected. I had been recently working on one of the detection platforms, affordable diagnostic platforms, paper-based, in which we were using the paper-based lateral flow device for HCV diagnosis, the hepatitis C virus diagnosis. I think similar kind of system can also be developed for a diagnosis of COVID. And we were using the HCV antigen for detection, not the antibody, because we were aiming at the early detection. So after telling you what are the ways that you can do the diagnosis, we have the RT-PCR, actually the positive rate of detection is only 38%. and this is the most reliable method, is what they call. Just imagine how many false positives, how many false negatives can you get with this particular method. Okay, then we have reverse transcription loop mediated isothermal, yeah, RT lamp process, that can also be done, that can detect a little faster, and the similar kind of tests have been used for detecting MERS viruses. Now when we talk about the nasopharyngeal, I just told you about the throat swabs. Those are the nasopharyngeal swabs and oropharyngeal swab tests. These are they are used for standard assessments, but even the positive rate for this is also only 53%. So this is the antigen based, right? This is the antigen based test, it's only 53%. Generally, the QRT-PCR, this is also a very important question. It can be a very important question for you. A piece of information always to be kept with you. Quantitative RT-PCR assays actually are targeting two regions, ORF1b and the N region, or the nucleocapsid region. Okay, as I told you in the beginning, that the nucleocapsid region we are using for as a diagnostic marker, so that's how you use it here. Okay, and now novel RT-PCR methods are also being developed, but the need of the time is for highly sensitive and specific assays to help improve the laboratory diagnosis of COVID-19. Now, how can this be done? By automated solutions for molecular diagnosis to handle large number of samples at the same time, right? It's very important in life. So, when we are talking about the diagnostic, we